Welcome to the Deep Dive. Today we're tearing into a really foundational piece of hardware, the Thor Broadcast H-16ATSC-IP.
Yeah.
Our mission here is to really understand how this one box bridges traditional broadcast airwaves, RF, with modern IP systems.
And what's fascinating is that this thing is the physical point where those two worlds slam together. It's essential for any system that's managing a huge data transition.
Right.
I mean, our sources even point to its historical role as an ATSC lighthouse station during that whole ATSC-3 transformation.
Wow, okay, so it was critical for making sure old and new standards could actually talk to each other.
Exactly. It kept everything running.
So let's get into its core function. This model, the H-16ATSC-IP, it seems to be all about massive scale.
It is.
It's a gateway that takes 16 independent off-air ATSC inputs.
16, which is just an incredible number for one device.
And it converts them all into IP transport streams.
And the output numbers, that's where the story really is. It can push out 512 simultaneous IP streams. But the real insight isn't just the number, it's the function. They call it an ATSC cherry picker to IP gateway.
A cherry picker. I like that.
Yeah, because most boxes just move the whole stream, the MPTS. This thing's like a surgical tool. It can isolate and convert only the specific subchannel you need into a UDP or RTP stream.
So it's not just about moving data, it's about massive bandwidth saving by only taking what you need.
A huge deal for network efficiency, exactly.
Now, what really got my attention was the flexibility on the input side. Those 16 tuners aren't just for ATAC, right? The specs show they can also handle DVB-C QAM or even DVB-SS2 signals.
That's right. And that versatility is so key. Wait, hold on. DVB-SS2, that's satellite.
Yep.
So are you saying a broadcaster could realistically pull in a satellite feed and integrate it directly into their QAM lineup with this one box?
Absolutely. And that gets to its other role as a unique transmodulator.
Okay.
It's built for mixing and matching. You can take an ATSC signal, convert it, and then output it as both an IP stream and a QAM signal at the same time.
So operators can just, add new channels or totally rearrange their lineup without needing a whole stack of different converters?
That's the idea.
Wow. That kind of dynamic flexibility, it must demand absolute precision in the data handling.
It has to.
High capacity means nothing if the quality is bad. You mentioned some key technical features like PCR adjusting and PSI editing.
Right. So let's break that down for everyone. PCR, PSISI. Why should an operator care about those acronyms?
Well, PCR is program clock reference. It's absolutely critical for timing. It's what gets rid of jitter and makes sure your video stream is stable.
Got it.
And PSISI editing, that lets you control the program and service information. So that's the channel guide data your users see, right? You get real-time control over the EPG.
Okay, so total control and a stable stream.
Plus, the signal itself is incredibly clean. The specs boast an M-error of 40 dBs or higher.
And it's impressive that a system managing all that conversion and quality control, 512 streams, can fit in such a small package.
That really is the big takeaway on the logistics side. The whole thing is just one rack unit, a 1RU device.
Right.
And you manage it through a web browser, it only pulls 25 watts of power. It is the definition of efficiency.
So it's the investment for that kind of capability.
Just for context, today's price is around $4,500. It's TAA compliant, and it comes with a 2-year warranty.
This really redefines what a head-and bridge device needs to do. The Thor H-16ATSC-IP shows the future isn't about separating RF and IP. It's about blending them seamlessly in one powerful box.
It does, and that leaves you with a really big question to think about. If this single 1RU device can handle 16 inputs, manage 512 IP streams, and mix all these global standards like DVB-T, ATSC, and QAM, what does that tell you about the future of physical infrastructure? How much processing power can we realistically pack into such a tiny footprint when the demand for dynamic content is just growing exponentially? Something to think about.